Hello students, we are discussing chapter 4 matter. In matter we are discussing gases. In the last class we discussed liquids and solids. Now we are discussing gases. In gases you can see the diagram or else this diagram. Here you can see in gaseous these whatever it is gaseous nothing but oxygen, hydrogen, nitrogen or else air, you can take any gas. Okay, in gaseous the molecules are very loosely packed. The molecules are loosely packed, but in liquid state the molecules are loosely packed. Even in liquid state also the molecules are loosely packed, but comparing to liquid, in gaseous the molecules are very loosely packed and the intermolecular space is maximum. Nothing but in liquids the intermolecular space is less, but in gaseous the intermolecular space is maximum. You can see the molecules here. Suppose in liquid state the molecules are like this in liquids, but in gaseous the molecules are very loosely packed and the intermolecular space is very high. Got it? So if the molecular space is maximum, the molecular force of attraction is weakest, isn't it? You can see the molecules, the space between the molecules in gaseous or the space between the molecules in liquids. The intermolecular force of attraction is very strong in liquid state, in liquid, and comparing to the gas. In gas the intermolecular space is very low, so the intermolecular force of attraction is also very weak, but in solids the intermolecular space is very strong, isn't it? Here in solids the molecules are tightly packed. Nothing but the intermolecular force of attraction is very high comparing to liquid, and comparing to gaseous the liquid intermolecular force of attraction is very high, but in gaseous the intermolecular force of attraction is very weak comparing to liquids and solids. And the force of intermolecular space is also maximum. Got it? They have neither a fixed shape nor a fixed volume. Nothing but if you take a gas in a beaker, okay, if you take a gas in a beaker, this is a gas. Got it? So in a gas we can see the gas in a beaker, isn't it? That can be a neither it has a fixed value nor it has a fixed shape, isn't it? Now they take shape and volume in a container when they kept in, isn't it? That is true. Yes, in a beaker we can see a gas and we can see the fixed volume of a gas and we can see the fixed shape of a gas in a beaker. Okay, gases have neither a definite shape nor a definite volume. As I discussed now, gases have a neither definite shape nor a definite volume. How? As their molecules are passed away from each other, they are negligible force of attraction. Here, you can take, in a beaker we are taking a gas. Okay, this is a gas. This is have a definite shape and definite volume. The force of attraction, nothing but if I applied a force of attraction, okay, if I applied the force over the beaker, isn't it? The gas will come together, nothing but, and the molecules will come together, isn't it? Once if applied stopping force, the molecule will replace on their own position, isn't it? So these have a definite shape and definite volume when they are in beaker, and the force of attraction is also very weak. If we apply the force of attraction, the molecules are come together. If we leave the beaker to, if you leave the force by beating the beaker, then the force of attraction is very low, they can't move. When the force of attraction is very high, the molecules can't move, isn't it? The molecules come together. If the force of attraction is very low, then the molecules can freely move in a beaker, isn't it? This here, if we apply the force of attraction to the gas, the molecules cannot move freely. They come closer, isn't it? If we stop applying the force, then the molecules can freely move and they can go by their definite positions. So they have definite shape and definite volume. Got it? Gases have maximum fluidity, nothing but fluidity, nothing but flow. Fluidity, nothing but flow. Got it? Yes, gases can flow. We know that because gases are loosely packed, they can flow easily. They have large intermolecular space and the intermolecular force of attraction is very weak and they can flow easily. So they have maximum fluidity. Got it? Gases are highly compressible. Nothing but highly compressible. Yes, these gases are highly compressible. For example, if I take LPG gas, liquefied petroleum gas, isn't it? We know about this gas, isn't it? What will happen in this gas? Okay, this is a gas, isn't it? In liquid, this is LPG, nothing but liquefied petroleum gas. How liquefied petroleum gas is happen, no? By continuous flow of attraction is very high here, nothing but by applying the force. Here in LPG gas, they applied the force and they convert the gas into liquid. By applying a lot of force, then the gas converted to liquid and they kept this. This is liquefied petroleum gas. When once we open the knob, the sound will come, isn't it? So this is a liquefied petroleum gas. So while compressing compressing a lot of force, then the gas turns into the liquid, isn't it? So these gases are highly compressible and while applying the force, isn't it? So as they have large intermolecular space, these gases, they are highly compressible. As they have large intermolecular space, they are highly compressible, isn't it? Yes, gases have very low density. Yes, these are having very low density, isn't it? As number of molecules per unit volume is very low, as they have low density, we can see that the molecules can freely flow here in a gas, isn't it? Why they will? These are loosely packed, but the density is very low. The nothing but the volume is very low. Got it? This is all about the gases. Now this is chapter 4, matter, gases. If you like the video, please share and subscribe my video. Thank you.